Hey there, class. Mr. Husky here. Hope you're having a good day so far. We're continuing with Chapter 7, which is roots, radicals, and inverses and that kind of stuff. Today is 7.4, Day 2. Our essential question is, can I graph the inverse of a function? How do I determine if a function has an inverse? And how do I determine if the inverse itself is a function? All right, so you'll recall from yesterday, or not, maybe not yesterday, but whenever we did 7.4 day 1, that the inverse is when you graph something over the line y equals x. So here's the line y equals x, kind of a rough sketch. It's a little off, but it'll work. This is y equals x. It's a 45-degree line. This is actually pretty bad. I'm going to try to fix that. You won't see that I'm fixing it here, but I'm going to try to do it a little bit better. Hopefully this will look a little bit nicer. Just a little bit nicer. This is y equals x. Okay, so that's the line y equals x. So basically we're going to graph over the line y equals x. So let's go ahead and the way you do that is you find points and then you're going to switch x and y, okay? But basically you can reflect it over the y equals x line. So let's go ahead and do that here. So we're graphing the line or the function y or f of x equals x squared plus 1. So if we graph the points -1, or sorry, -2, -1, 0, 1, and 2. So basically you're just going to plug like those into your calculus. We would do parentheses -2 squared plus 1, for example. And when we do that, you're going to get 4, and 4 plus 1 is going to be 5. And then if you do parentheses -1, we're plugging in wherever we see, we're replacing x with -2. We're replacing x with -1 now. And -1 squared is 1, 1 plus 1 is 2. All right. So you just plug in those values, and also once you find you probably should find the vertex here first for this problem. The vertex is going to be 1, and then also because it's a parabola, which is an x squared plus 1 thing, it's also going to be 2 and 5 over here as well. Okay, so if we graph these points, we have -2, 5 is left 2 up 5, 1, 2, 3, 4, 5. We have -1, 2 is left 1 up 2. We have 0, 1, which is stay on the x-axis, go up 1. Then we have 1, 2, right 1, up 2. And then we have right 2, up 5. 1, 2, 3, 4, 5. And we can see it's going to make a parabola. And there we go. There's our graph. Okay? And then, so to find the inverse, all we need to do is once we find the original points, all we need to do is switch x and y. Okay, so instead of -2, 5, I'm going to do 5, -2. Because that's what it means to be the inverse, is to switch the x and y. And we got 2, -1, 1, 0, 1, 2, and then we have 5. Oops, I think I goofed something up there. I actually meant to do 2, 1, and then we have 5, 2. Make sure I double check this right. So we got 5, -2, 2, -1, 1, 0, 2, 1, and 5, 2. Good. All right, so let's graph these. So we're going to go 5, -2 is right 5 down 2. 2, 3, 4, 5 down 2. Then we have 2, -1. We go right 2 down 1. Then we have 1, 0 is right 1, stay on the x-axis. 2, 1 is right 2 up 1. And then we have right 5 up 2 for 1, 2, 3, 4, 5 up 2. You can see it's kind of a parabola that's on its side. It's been reflected over the y equals x line. And there's our inverse, okay? Now the question is the inverse of f of x a function? So the way we determine whether the inverse is a function or if any relation is a function is all we need to do is what's called the vertical line test. So if I draw a vertical line, so for example, if I draw a vertical line through this red graph right here, you can see it's only going to cross. Those are not really great vertical lines, but the vertical line test means that when you draw a vertical line through any point on a graph of a relation, it should only cross the graph once. So you can see these blue lines are going to cross only once. They're only going to cross once when we draw a vertical line. But this green one, if I draw a vertical line, well, let's just draw a vertical line right here. Here's a vertical line. You can see that it crosses in 2 spots. So is the inverse a function? The answer is going to be no, because it does not pass the vertical line test. I like to call it the VLT, to kind of for short, okay? So that's how you determine whether a graph is a function, is you take a vertical line anywhere on the graph, it should only cross the graph once. If it does not, it is not a function. If it does, it is a function. Okay, let's do example 2 now. We have a little bit harder one here. Okay. It says graph the function and its inverse. We have f of x equals 1/2 x to the third minus 2. And let's make sure we draw our y equals x inverse line right here. This is y equals x. All right, so let's go ahead and make some points here. So if we plug in these points, again, I just use -2, -1, 0, 1, and 2. Those are some good points to plug in. So if you plug these into your you're literally going to plug that into your calculator. You're going to do 1 divided by 2, and then do actually I'll show you how to plug this into your calculator. Actually, okay. So you're going to do parentheses 1 divided by 2. Oops. And then you're going to do parentheses -2 to the power of 3. And then -2. That's kind of how you're going to plug into your calculator. You're going to plug into your calculator exactly as you see it. And the numbers you get when you plug in -2 in for x, you're going to get, so basically we did 1/2 times -2, oops, to the third minus 2, right? -2 is going to be -6. -1, you plug in -1, you're going to get -2.5. 0 is going to be -2. And net 1 is going to be -1.5. And 2 is going to be 2. So let's go ahead and graph these. So we got -2, 6, left 2. Oh, it's -6 actually, sorry, my bad. And yeah, okay, so left 2 down 6. Left 2 down 6. Then we have -1, -2.5, so that's left 1 down 2.5 boxes. Then we have 0, -2 means go down 2. Then we have 1, -1.5 means go right 1, go down 1.5 boxes. Right, 1.5 is down 1.5. Then we have 2, 2, which is right 2, up 2. So this is kind of a weird shape we haven't seen before. This is what it's going to kind of look like. It's going to go like this. It's going to have an inflection point where it's going to kind of switch direction. And then it's going to go up like this. So there is our original graph. Now to find the inverse, all we have to do is switch x and y. We're going to switch x and y, okay? So instead of -2, -6, I'm going to have -6, -2, and then -2.5 and -1, and then 0 and -2, and then -1.5. Oops, I goofed up again. Not good at flipping these around, apparently. So we got -2 and 0. We have -1.5 and 1, and then we have 2 and 2. Make sure I did these right. Okay, let's graph these now. So we have -6, -2 is left 6, down 2. Then we have -2.5, -1 means go left 2.5 boxes, up, down 1. Then we have -2, 0 means go left 2, stay on the x-axis. Then we have -1.5, which means go left 1.5 boxes, up 1. Then we have 2, 2, which means go right 2, up 2. So you can see it's kind of the same thing. We want to turn your paper sideways a little bit. It's going to go the same thing. It's just going to be kind of go like this. It's going to change direction and go like that. Okay? All right. So, question for you, is the inverse, which is the green line, is that a function or not? Well, we want to check the vertical line test. The original function, if we take a blue line anywhere on the red graph, it's only going to cross once. And the same thing can be said for the green line too. If you draw a graph anywhere, it looks like in the middle here, it looks like it might be kind of close, but it only crosses once, okay? So the answer is yes, because it passes, or it does pass the vertical line test. Okay? All right, and that's how we graph inverses. All right, now we're going to do something called the horizontal line test, which is how you check whether a graph of a function, whether its inverse will be a function before you even graph it, okay? Well, I mean, I guess you kind of have to graph it, but before like finding the inverse and graphing the inverse, you can tell whether it's going to be a function or not, which is kind of cool. So the horizontal line says if no horizontal line intersects the graph of a function more than once, then the inverse of f itself is itself a function, okay? So basically it's like before we flip the graph by flipping it over y equals x and finding the inverse using graphing by switching x and y, if you do a horizontal line test, you can tell whether after you flip it if it's going to be a function before you even flip it, if that makes sense, okay? So basically, because if you look back at the original function here, if we had like, so if we do a horizontal line test through this red parabola up here, if I did a horizontal line test, I can see that when I flip it, it's going to intercept in these two spots already. So when I flip it, it's also going to flip in those two spots, right? So if I take an original function and I see that if I draw a horizontal line before I flip it and it crosses more than once, then when it does flip, it is going to fail the vertical line test, okay? All right, let's get into this here. So it says graph of each function. We have f of x equals x squared. X is greater than or equal to 0. So we need to make an xy table for this. Make an xy table. Okay. I'm just going to use, so x has to be greater than or equal to 0, so I'm going to start at 0. 0, 1, 2, and 3. All right. And if I plug in these numbers in for x into this original equation over here, or this original function, I'm going to get 0, 1, 4, and 9. Okay. So let's graph those. We have 0, 0. We have 1, 1, right? 1 up 1. We have 2, 4, right? 2 up 4. And then we have 3, 9 is going to be off the graph. So we're going to draw kind of like a half parabola here. And if I do a horizontal line test, if I take my blue line and I draw a horizontal line anywhere on the graph, is it going to cross more than once horizontally? The answer is no. If we had just y equals x squared and we did not have this, it would fail because we would have the second half of the parabola, which would fail, right? Because it would cross more than once, but we do not have that, so that's good. So in this case, the inverse is yes, and the reason why is it passes the horizontal line test. So the vertical line test is for the original function. The horizontal line test is going to be for inverses. All right. Next graph we have is f of x equals the absolute value of x plus 2. We're trying to find whether the inverse is a function, okay? So this is going to be an absolute value graph, which is going to look like a V of some sort. So we need to make an x and y table for this. All right, so I'm going to use the points. Let's see here. We're going to make kind of a big -3. Let's try -3, -2, -1, 0, 1, and 2. You'll see later on how I pick these numbers. There's a way to tell how to graph these to find the right points, but you can pick any points on the line. But if you pick numbers to the right of the y-axis and stuff, if you don't pick the right x values, you're probably not going to see the whole graph. So in this case, just stick with me for this. We don't really care what ones you pick, but you want to make sure that the x's that you pick are going to be on the graph, and then it's going to show like the whole behavior of the graph, right? So it should be a v because this is an absolute value function. So if you don't see a v, you probably have to go either further left or further right. All right, so if we plug in -3, we're literally going to do we're going to plug in -3 in for this equation. So the y was absolute value of x plus 2, I believe. Yep. So we're going to plug into there. So we're going to take -3 plus 2. We're going to plug it in for x, and that's going to equal the absolute value of -1, which equals 1. Then we have absolute value -2 plus 2. -2 plus 2 is 0. Absolute value of 0 equals 0. Then we have absolute value of -1 plus 2. And absolute value of -1 plus 2 is absolute value of 1, which equals 1. Then we have 0 plus 2 in absolute value, which is absolute value of 2, which equals 2. Then we have 1 plus 2. Absolute value of 3 equals 3. And the absolute value of 2 plus 2 equals absolute value of 4, which equals 4. So these are the points we're going to plug in here. We have -3, 1. So we're going to go left 3 up 1. 1, 2, 3 up 1. We're going to go -2, 0. Left 2, stay on the x-axis. We got -1, 1. Left 1, up 1. We have 0, 2. We're going to go up 2. Then we have 1, 3. Right 1, up 3. Then we have 2, 4. Right 2, up 1, 2, 3, 4. Okay. So now we got to graph this. You can see it's going to make a V. That wasn't a great line. Let me fix that. Okay, so now we need to check if it's the inverse is going to be a function. The way we do that was with a horizontal line test. If I draw a horizontal line, you want to be kind of strategic about how you graph your horizontal line. If I graph it right here, you can see it's going to cross there and there. So is the inverse a function? The answer is no. It fails the horizontal line test. Okay. All right, and that should be all I have for you today, I believe. So thank you for watching. Have a great day. We'll talk soon.